In this video, I'll be going through the 3E end of year Pure Physics 2021 paper. We will begin with question 5 and most likely we will end with question 8. So anyway, 5A, you are asked to state the principle of moment. In view of the very small syllabus, any mistake you make in the definition will be considered as 0, right? So it is either you get 1 or 0. So in this question, to state the definition, there are many parts. First, you must tell me the condition for the principle of moment. It is a condition for bodies in equilibrium. Then after that, you need to highlight to me that it is not just 1 or 2 clockwise moment, but it is the sum of clockwise moment about the pivot. And this sum of clockwise moment about the pivot needs to be equal to the sum of anti-clockwise moment about the same pivot. Okay, so you need to have all 1, 2, 3, 4, 5 components in order to get it right. Okay, then for B part 1, it is a standard moment question, and this time around we are being very kind. We only give you 1 force and 2 forces to consider. So it is a rather simple moment question. If you got this wrong, it means that you really need help or you need to change your way of approaching the question. So as you can see here, this student couldn't even solve this moment question. It is not because she didn't prepare well, it's because of the way she approached it. It is still very old school. It is like primary school whereby you do a statement and then you take a formula and then you equal and then you take the same thing and then you equal. Because the student is doing a lot of this manipulation in her mind, this mind process will overrun your memory and you make a mistake, as you can see over here, and basically your effort is all gone. So rather than taking a risk of overrunning your memory, why not you just listen to your teacher and follow the approach that we have taught you. So what is the approach that we have been trying to convince you to take? Write down properly the principle of moment and be very clear and have this habit to state where you are taking the moment, where is the pivot that you try to use as a reference. So down here, if you do it properly and you do it in steps, you should have no issue. But if you are stubborn like her, then I'm not saying that she is a bad student. I'm saying that she just takes shortcuts thinking that it is beneficial. But we have been trying our best to tell you that shortcuts will not always bring you to the destination that you wanted. Yeah, it may appear to be time saving, but in the end they may bring you to the wrong place, which is in this case lose marks. So please listen to me carefully on how to do it. So what you need to do is that you analyze each force. So for example, if I want to analyze 30 Newton force, I would say that okay, this 30 Newton force will give me the anti-clockwise moment 1. And then when I analyze the tensional force, I will say that okay, it gives me the clockwise moment number 1. And because there are only 2 forces, there will only be 2 moments. So now I've identified the moment, clockwise and anti-clockwise. I can then put it into my moment statement, right? I know that the sum of clockwise and anti-clockwise moment must balance, so that's why I write the yellow line. Then from ACW1, so I know that very clear now, ACW1 is produced by the force 30 and the perpendicular distance that is involved is 20. You will also notice that I didn't change the cm into meter. Now I tell intake, okay, I'm done with my ACW1. Now I look at CW. So for CW, I know it is tension. So I will put T because I do not know what is the force over here. But I know that it will be having a distance like this. So you see, even I make the mistake, right? But luckily, because of the system that I put in place, I do it slowly, I will be able to spot it. It's 1.5 cm. So now that I have one unknown, oh, by the way, I'm also trying to show you that why I didn't convert the cm into meter, because eventually the equation will cancel the effect of cm and meter. So if you do this correctly, you will actually find that the tensional force is actually 400 Newton. So down here, what did she do wrong? Well, she convert 20 to meter, but then she forgot that 1.5 is still in cm. So if you decided to convert this into meter, then you must convert this into meter as well. If not, you will result in an error. So that's why I strongly advise you. By the way, if you are doing it like that, I can tell you frankly and with a lot of confidence that set 4 you won't be able to do well, because this is just two moment. In set 4 we won't be giving you two force system. We will give you a system that involve 4 to 5 forces. Each force will produce its own moment, and we will give you a question with multiple possible pivot. So if you still want to do it this way, where you do many of the deduction in your mind, we will be pretty sure that you will be overrun and you will make mistake along the way. So you need to learn from set 3 to actually adapt a very good way of presenting your data, so that this presentation will help you organize your thoughts. Okay, so I cannot stress anymore. Okay, then for part 2, so for part 2 is the same thing. If you have something like this, you can actually see it very clearly, right? You see how the way I see it is that once you have this, you can see that T is given by what? Force multiply, this is the force, right, that you apply, multiply by the distance over 1.5, right? So if you want to keep, you see this question is trying to tell you what? You want the force on the brake lever to be the same. So meaning that this guy, you want to keep it as constant, the green one. And they say that you want the minimum applied force. So minimum applied force meaning that you want to keep this one small. So if you want to keep this one small, and then you want to keep this as a constant, what does this show you in mathematics is that this D, you want it to be as big as possible, right? So that's the beauty of writing it in this manner, presenting it in this manner, because if you are doing it your way, you won't be able to see any relationship. It's just lines and lines of statement that is isolated from each other. Okay, so how do I approach this? Well, what the question is saying is that should you apply a force here or should you apply a force here? And I think that once you see this, it is pretty convincing that you would want to apply it at x, right? Because if you apply it at x, you basically maximize the distance. So in this case, for your part 2, you would want to apply it at x, and you are asked to explain, right? So in physics, if you want to explain anything, the easiest approach that you should always rely on is to quote the formula that describes the system. So in this case, we know that it is about moment, so I will quote m equals to F times t. The requirement is that you want to produce the same moment with the smaller force. So if you want to do that, then you need to maximize the D. Now in this particular test, we'll give you we will lower the marking demand. So if you just put D is maximum, we'll give you the full mark. But in set 4, you are expected to describe what is this D. So this D comes with a long name. First of all, you must tell me that it is a perpendicular distance. Whenever you mention distance in physics, you must tell me it's between what and what. So in this case, it is between the pivot. Pivot is a point, so you cannot be perpendicular to a point. Something must be perpendicular to a point. So the something is the line of action of F. Okay, this line of action refers to, for example, if now I have, this is my pivot, right? And now I just have a random force like this. This is my F. So what is line of action of a force? Line of action of a force basically is just this black color dotted line. So what does this mean? Perpendicular distance between line of action. So I can measure a lot of distance, right? This is distance, this distance, this distance. All these are distance between pivot and line of action. But there can only be one perpendicular distance. So Therefore, this definition, this description of perpendicularity is important. You need to learn it. Okay. Okay, for question 6, again, if you do not have a system to do it, you will get wrong very easily. So luckily, she managed to remember what I taught her and she applied it. So what she have done is that from the table, she sketched a graph next to it. So you can see that by sketching this graph, she produced two coordinates. First coordinate is 80, 860, and then this coordinate here would be 0, 800. So with this coordinate, what she did is that she take these two coordinates, try to find the gradient, and she know that there's an unknown pair of coordinate over here, which she call it x and minus 24. So if you do it this way, because you are assuming that the graph is linear, so gradient of any 2 point will always be the same. So you can solve it, and very well done. In this case, if you make the 2SF error, we will condone you. It is a special case, but I do not want to tell you why. So it is safer if you actually turn this into 2SF. Okay. Okay, for the next part, a lot of you are misinterpreting the question. So the question is telling you that the reading change is changed by 15 units. So you can either change it by positive 15 units, right? Or you can lower it by 15 units. So with the reading refers to the 782 that you have calculated. And so if there's a change of 15 units, these are the two new ones. And they are asking you what is the temperature reading. That means they want it to turn back into degrees Celsius. So basically this question is telling you that if I have 797, what is my temperature? 767, what is my temperature? And similar to mathematics, although in the previous answer this is 780, when you want to use the same value in the next part, please use the before round up value. Now this is only applicable for your theory paper. Practical is different. So use the same method, you should be able to solve it. For the purpose of the correction, please show your full working. I want to see the full working. If there's no space, just use a post-it note, post it next to it. Okay, the correct answer is about negative 44 and negative 4.0. Okay, for question 7, it is your KMM question. So if you look here, 7a, it is a common mistake. You can see that the name of the model suggests that it is of matter. But if you look at this phrasing, there are many tiny particles in constant random motion. Your statement's subject is about particle. This model is not called kinetic model of particle. It is called kinetic model of matter. So as a result, your definition should begin with matter. That should be the subject of your definition. So matter is made up of many tiny particles that are in constant random motion. So that's why this is called kinetic model of matter. Okay. So for 7b, she answered very well. Okay, I can see that she has prepared. That's why I said that she has prepared. Okay, it's just that while doing the paper, she get overwhelmed because she do a lot of the processing in her mind, and obviously she tired herself out. So for part B, how should you approach it? Well, in KMM, there are several things you will talk about. For example, you talk about the trigger. So the trigger here is temperature rise. Then after that, you will just say the effect. The speed of the molecule will increase. Actually down here, you don't really need to talk about things that are in constant. So in this case, there's no mark for it, but she did it for completeness, and I appreciate it. Okay, so it is correct. Average number of molecule per unit volume is constant. The collision frequency and the force will increase, and you need to state very clearly that the collision is between the gas molecule and the wall of the cylinder. Then finally state the formula by P equals to F over A, the forces will increase while the A remain constant. So as a result, pressure will increase. So because the pressure is now larger than the surrounding pressure, you would definitely need to exert a larger force. So unfortunately, the last statement, I can't really make out what she's writing, so I cannot give her the mark. So down here, I would need you to continue since your pressure in is larger than your pressure out, the force exerted on the piston must increase to keep the piston in place. So that would be a complete answer.